I hope you're all nice and warm and safe. We are going to finish our notes for chapter 4 today. So I'm on page 56, and I'm looking at number 5, which says, Milwaukee is directly west of Grand Haven, Michigan. So put Milwaukee over here and Grand Haven over here, on opposite sides of Lake Michigan. On a foggy night, a law enforcement boat leaves from Milwaukee on a course of 105 degrees. So 105 degrees would be like this. Remember, navigationally, we start due north at 0. And a small smuggling craft steers a course of 195 from Grand Haven. So that would look like this. The law enforcement boat averages 23 knots and collides with the smuggling craft. So this makes a triangle here. They hit each other right here. The law enforcement boat averages 23 knots and collides with the smuggling craft. What was the smuggling boat's average speed? Well, they're traveling at the same speed. So I can call, and they're traveling the same amount, not the same speed, the same time. They're traveling the same amount of time. So this guy is traveling 23 miles an hour. Wait, yeah, he's law enforcement. He's traveling 23 miles an hour for X hours. So I'll just call that 23X. And this guy, I don't know how fast he's going, but he's going for X hours also. So I'll call him YX. And Y is the speed of the smugglers. Now actually, these X's aren't even important because both boats are traveling the same amount of time. So time really is inconsequential. So if that's going to confuse you, we can just take those out. We don't even need those. We want to know if this guy goes 23 miles in 1 hour, how far will this guy go in 1 hour? That will be his speed. Okay, so let's talk about this a little bit and see what we can figure out. This angle right here would be 15. Would you agree with that? 90 plus 15. And this angle right here, now that's 195, that's 270. So wouldn't this be 75? Voila. If that's 15 and that's 75, isn't this 90? So we have a little right triangle, and we want to know what this is. So, I don't know, pick an angle. With regard to the 15, this is opposite and adjacent. This would be hypotenuse. So we'll just say tan 15 equals y over 23. So the speed of the smuggler is 23 tan 15. Whatever that is, make sure your calculator's in degrees. And 23 tangent 15. So about 6.16. Knots. Nautical miles per hour. Knots. Good. Good, good, good. I think that was the only question. Okay, number 6. Oh, the picture's already drawn for you in number 6. So we've got a boat out here, and he is looking, or we have bearings from 2 points on the shore that are 550 feet apart. And we know this angle is 110, and this angle is 100. And that's all we know, but we want to know how far the boat is from the shore. So that's my unknown. How far is the boat from the shore? Not how far is he from each of the points, but how far is he from the shore? So that would be the perpendicular distance. This is the shore. All right. Well, what do you think? We know that this angle is 80, right here, which makes this one 10, if we care about that, that would be 10. And I can say, I'm gonna call this Y. I can say that the tangent of 10 equals Y over X. Now, that isn't going to help me right now because it's got too many variables, but we did one of these the other day. Now, let's look at the big triangle. In the big triangle, we know this is 70, so this is 20 in the big triangle. And we can say the tangent of 20 equals Y plus 550 over X. So the tangent of 20 equals this whole side over X. Can't solve either one of those alone, but we have two variables. So we're just going to go ahead and substitute. So X tan 10 equals Y, and X tan 20 equals Y plus 550. So can I go ahead and plug this into here? Why, yes I can. So what equation am I going to have? It's going to be kind of messy, but I'm going to be able to solve it. So let's see, we'll have X tan 20 equals X tan 10 plus 550. Just plugging this value of Y into here, substituting. So now I'll put my X's on the same side. We did something like exactly like this. I hope you remember just recently. So now I'll factor out the X. And I'll divide. And actually, is an X what I'm looking for? It is. So this is just going to give me my answer. So let's type it in. Here we go. 550 divided by tangent 20 minus tangent 10. I hope I typed this in right. I messed this up the other day. I got 2931.09. Would be feet. Well, I hope that's right. I'm sure if it's not, you'll let me know. All right, let's try the next one. Last one. All right, last one. Ranger spots a fire. Yeah, I gotta erase this. All right, Ranger spots a fire from a 73-foot tower. Here's spots of fire, here's the fire, here's the ranger. She measures the angle of depression to be 1 degree, 20 minutes. How far is the fire from the tower? Oh, this is an easy one. Easy, easy, easy. Nothing fancy about this one. Here's our angle. We got opposite and adjacent, so tan 120 equals 73 over x. Perfect. So 73 divided by, remember how to put that in, tangent 1 second angle degree, 20 second angle minutes. I got 3136.4 feet, I think. Yeah. Okay. All right. Now what we're going to do, that's it for the chapter. We finally made it through chapter 4, humongous chapter. So what I'm going to have you do now, and you'll probably have to stop the video while you find all this, but in Schoology, I put a second review. I gave you a hard copy of the first review, but in Schoology there is a second review, review 2, for chapter 4, and I'd like you to get that out, and we're going to do a few problems from it as we prepare for this massive chapter 4 test. Chapter 4 is just so big. All right, so you're finding review 2. And, I mean, you're not here to ask me questions, specific questions, so I'm just randomly choosing a chunk of questions. So I'm going to the second page, and I'm just starting with number 13. I'm just going to do a few problems. They're just random, nothing special about any of them, but we'll just start with 13. Okay, so I'm on review 2, problem number 13. It says an angle X is in standard position with X between 0 and 2 pi. So that means that whatever my angle is, it's one time, it's somewhere in there. Standard position, someplace in there. In which quadrant is this angle? If the secant is positive, so the secant is positive, and the sine is negative. Groupies, do not be confused by this. This is a super simple question. If you remember, secant is the reciprocal of the cosine, and the cosine is associated with x. So if the secant is positive, it means x is positive. The sine is associated with y over r. R is always positive. So whatever the sine of y is, that's going to be the sine of the sine. Y is negative. In which quadrant do you have a positive x and a negative y? That's all. That's the answer to the question. Which quadrant is it? Well, wouldn't it be down here in quadrant 4? Positive x, negative y. That's all there is to that. Do not let it confuse you. Find the period. Okay, so here is my function. And it is composed of 2 different functions, both periodic, added together. What's the period of this guy? Gotta remember, oh, there's so much to remember. The period of the tangent is pi. Remember, the period of all of the functions is 2 pi, except tangent and cotangent, they are just pi. The standard periods. All right, what's the period of this guy? Well, it's cosine. So it starts out as 2 pi, but it's being divided by 4. So think about this picture, whatever wackiness it has, it's going to be very weird, definitely not a sinusoid, it's going to be a very weird thing. But this piece of it repeats every pi. This piece of it repeats every pi over 2. So the period of the whole shebang is pi. All right, look at the next one. Now there's a bunch of numbers in here, but none of it matters. None of it makes any difference in this particular problem, except this guy and this guy, right? Those are the things that are going to impact my period. So the period of this one is 2 pi over 8, which is pi over 4. And the period of this one is 2 pi over 6, which is pi over 3. So think about that. This one repeats every pi over 4. So 1/4, 2/4, 3/4, 4/4, and so on and so on and so on. This one repeats every third. So 1/3, 2/3, 3/3, right there's your match, right? The period of that is also pi. They both start over again at pi, so the picture's going to start duplicating itself at pi. All right. Now, one of the most basic of all problems, we're changing negative 110 degrees into radians. You're smart people. You have figured this out probably in several different ways. I always, what works for me, it doesn't have to be your method. What works for me is, I know pi radians is 180 degrees. So how many radians are 110 degrees? That proportion just clicks with me. So I just set it up and solve it. So x is going to equal negative 110 pi over 180, or negative 11 pi over 18. Now again, I don't care how you do that. There are different ways to do it, and they're all good. But make sure you're getting that answer. That's the answer that we need to come up with. Okay? Get some erasers out here. Next. Change 1.5 radians. So this is kind of the same thing, but we're going the other direction. And we're doing it, we're answering in several different ways. All right, so here we go. Exact degrees. So it's 1.5 radians. So pi is to 180 as 1.5 is to x. Now this is going to be an exact answer. I'm not using my calculator. This is going to be an exact answer. So pi x equals, now when I say don't use your calculator, if you need your calculator to do the multiplication, you can. I think 180 times 1.5 is 270. But if you need a calculator to do that, that's okay. And then x equals 270 over pi degrees. That is your exact degree measure for 1.5 radians. Okay? Now, we're going to change that into decimal degrees. So you just take your calculator and you do 270 divided by pi using your pi button, and it's 85.94 degrees. That's your decimal from your calculator. Then you can take that decimal, go into second angle, and down to DMS, and say that's 85 degrees, 56 minutes, and 37 seconds, 37.209. Okay, so we changed 1.5 into degrees, into degrees, but we answered in 3 different ways. We answered exactly, decimally, and degrees, minutes, and seconds. Okay, 17 is something we've been doing just recently. We're going to solve this equation, but we got to be between pi over 2 and 3 pi over 2. Pay attention to that. Your answer has to be in that range, basically between 90 and 270 if you're thinking degrees. Over here. All right, so what do we know? We know the cosine is negative 1/3. Where's the cosine negative? Remember, cosine is associated with x. Where's that negative? Oh, well, interestingly enough, it's negative in both of these quadrants, isn't it? So this problem is actually going to have 2 answers. So I'm going to go to my calculator. This was my original direction, so I'm going to be set in radians. So I'm going to go in and set my calculator in radians. I've got to pay attention to that. Oh my gosh, there's so much to keep track of. And then second cosine 1/3. Just put in the positive because that's going to give you the reference angle, which is 1.23, and that's the angle that you need. You need that reference angle so that you can figure out what the actual answers are. So this is the radian measure of the angle whose cosine is negative 1/3. Well, is 1/3. So the answers are the angles in quadrant 2. So it's going to be the red one and the purple one. So the red angle will be pi minus 1.23, and the purple one will be pi plus 1.23. So I'm just going to type those in on my calculator. Pi plus 1.23. That one is 4.37. And pi minus 1.23, 1.91. And there are the answers to the question. Now you do need to be careful, because if this had been only, let's say, in quadrants 1 and 2, then you would only have one answer. Because if 1 and 2 were your quadrants, you can't have a negative over here, so the only answer would come from there. So you really got to pay attention to that and to this. All right, now we're going to do exactly the same thing, but we're not going to use a calculator. So that problem would be on the calculator part of the test. And number 18 would be on the no calculator part of the test. So sine x equals root 3 over 2. And I am between 90 and 270. So now I'm back in degrees, but it doesn't matter because I'm not using my calculator anyway, but I'm over here. 90 to 270. Remember, 0, 90, 180, 270. Okay, now the sine is a positive number. When I solve that equation, the sine is a positive number. Well, remember, sine is y. Sine is associated with y. Y is definitely positive in this quadrant, so I'm going to go ahead and draw it in that quadrant. Y is not positive down here. So even though this is an eligible quadrant, it isn't going to have a solution because the sign is negative down there. Y is negative down there. So my only answer is going to come right here. Opposite over hypotenuse is root 3 over 2. You know, if you're doing this without a calculator, it's a special triangle. That's a 30, 60, 90. That would actually be negative 1 there. And across from the root 3 is always 60. Please don't say the answer is 60, because it's not. The answer is 120. Okay? All right. Well, that's enough. We just did some word problems, so I'll let you work on those on your own. For next time that we have class, we need to do some more review. So I would like you to take a look at this review 2, the ones we haven't done from review 2. I'd like you to take a look at them, and I'll just answer questions. So pick out ones that you think you need to practice. Okay? All right, homework 4.8 will be due on, Wednesday, Friday. Homework 4.8 is due Friday. All right, thanks a lot, guys. Have a wonderful day. Be safe.